Welcome back everyone to this series of lectures on the CIFAR 10 dataset with convolutional neural networks. And in part 1 we're going to be focusing on the data itself. The CIFAR 10 dataset are essentially 32 by 32 images of 10 different objects: airplanes, cars, bird, cat, deer, dog, frog, horse, ships, and trucks. And keep in mind the main difference here than what we've done before is the fact that these are color images. So there's 3 color channels. So in this series of lectures, we're actually going to end up reusing a lot of the previous convolutional neural network code, and a lot of it's repeatable, so you'll be seeing me copy and paste from the lecture notebook for code that is essentially the same things we've already covered in the previous lectures. And we're really just going to be focusing on manually coding out new additions due to the introduction of those 3 color channels. So let's get started by loading up the data and viewing a batch of those images. Alright, I already done my imports, and what I'm going to do is load the CIFAR 10 dataset. This is actually almost the exact same way we loaded in the MNIST, we just need to change the method call here. So we're going to say transform is equal to tensor, since we actually want to load these up as a tensor. So we'll say transform is equal to transforms to tensor. And then we'll load in our training data using the datasets import, except this time we'll say CIFAR, and then we want CIFAR 10. We'll say root is equal to ... data, or you can save it technically to wherever you want. We'll say train is equal to true. We'll say download is equal to true. And then we'll say transform is equal to, transform. Okay, so go ahead and run that. And if you have not downloaded it yet, this will actually download for you. Keep in mind, if you have a firewall, you may get some sort of error message here, in which case turn off your firewall so you can actually download this data. The other thing to notice here is you may get this little warning here that says message rate exceeded. That's totally okay. You don't need to worry about that, especially just telling you that it's not going to keep updating this 30%, 31%, 32%, etc. So you don't need to worry about that. Right now, it's limited to 1,000 messages per second, so it was exceeding that, but you can still see here the cell was running, so you can ignore that. It's just a warning telling you, hey, we were sending out the information too fast. And I'm essentially going to copy and paste this for the test set. So we'll come down here and we'll change this from train to test. Then we'll scroll over and we'll say train here is false. And we'll go ahead and download that data as well. So then go ahead and download that, and then you, depending on where you're saving it, I already had it downloaded and verified, so I'm good to go. Let's go ahead and explore this. Just type in train data, and you can see we have CIFAR, so there's 50,000 training points. And if we take a look at the test data, there's 10,000 test points. Okay, so let's go ahead and create data loaders for these. We'll do this by saying torch, and we'll set a manual seed. As always, I just choose an arbitrary number, so your random shuffling is the same as mine. We will say train loader is equal to data loader, and this is essentially very similar to what we just did before. Pass in our training data, choose a batch size. This is something you can play around with. I'll go ahead and say a batch size of 10, and then I will shuffle this as true for the training, and then we're going to copy and paste this to the exact same thing for the test, except just call it test loader. So we'll say this is our test loader, and it takes in the test data. And in this case, we actually don't need to shuffle the test data, so we'll say shuffle is false. Run that. And now let's go ahead and define strings for labels. So technically, we could call the labels whatever we want, but the way these are indexed, the index 0 label is a plane, index 1 label is a car, etc. So we've actually set this up already for you. So just open up our notebook and copy and paste the list called class names. And the class names has these strings attached: plane, car, bird, etc. So I'll go ahead and run that. And now I'm going to view a batch of images. So what I'll do is I just want to grab the first batch of images. I'll say for images, comma, labels in train loader, and then I'm just going to break, just as we did before. So run that, and if you take a look at labels, it's essentially this tensor object. So if it says label 3, then that's a bird. If it says, actually it's a cat, so 0, 1, 2, 3, indexing starts at 0. 2 is going to be a bird, and then 0 is going to be a plane, etc. So then let's actually use that make grid functionality that we imported, just as we did before. So I'm going to say here, IM is equal to make grid, pass in the images, say number of rows is 5. Default row value is 8, so I just want to overwrite it there. And then we'll say PLT figure, and I'll make this a little larger by saying fig size is equal to 10 by 4. And then we'll say PLT imshow, and this is really just to make it look nice here. We'll say np.transpose im.numpy, and then we'll say the following, comma, 1, 2, 0. Essentially the same transformations we did previously. So if we go ahead and run that, we can see here, and again, these are only 32 by 32 pixels, so they should appear pretty blurry. But this very first image, that was tensor 3, and in fact we can label these, and there's some code in the lecture notebook that I'm going to copy over just for the labels. So let me go ahead and copy that over and then paste it here, essentially just printing out both the NumPy labels and the class names. So those are the class names we did here. So run that, and we can see the first one's a cat, this one's a bird, looks like a little kiwi bird. Next one we have is a plane, then we have what appears to be a deer, and then we have a truck, a dog, a car, bird, deer, and ship. Now, if you were to try to run an artificial neural network on this, it would basically fail, because you can see here, these images from one to the other look way, way different. And the fact that they're colored just adds another layer of complexity that really the artificial neural network would not be able to work well with. And if you don't believe me, you can go ahead and try running an artificial neural network. You can see if you can flatten out these images, but really it's just not going to be able to predict here. So what we need to do is use a convolutional neural network. So what we'll do in the next lecture is we'll go ahead and define the model, and we'll specifically focus on what we're changing from the previous model to this model in order to deal with the color channels. It's going to be really similar, except just a couple of key adjustments for that extra 2 color channels of red, green, and blue. Okay, I will see you at the next lecture.